So now we're going to put everything we've been learning together. We're going to graph and solve systems in both standard and slope-intercept form. Okay. All right, so you see standard form, right? Ax plus by equals c. You say, oh, I want to graph this. Oh, without me telling you this, you say, oh, I should find the intercepts. That'll be the easiest way to graph it. For the y-intercept, x equals 0. So we have 0, 4 is our y-intercept. The x-intercept, we're going to make y equals 0. Divide by 2. X equals 2. X equals 2. 2, 0 is our x-intercept. So this is the line for 2x plus 4y equals 4. Okay. There you go. The bottom equation is in slope-intercept. We're going to plot it. So it's at 0, negative 6, and a slope of 3. So over 1, up 3. Over 1, up 3. So we have 3 points there. Okay. Now, I didn't ask this, but what is the solution to this system? The solution is where they intersect. So in this case, the solution, right, is where they intersect. It turns out it's the x-intercept of both of them to 0, but it's not always the x-intercept. Okay, so there was a lot of stuff there. Let's keep going. Whoops, I had already graphed that. Same thing. All right, so the top one is in standard. So you graph it using the intercepts. Oops, the intercepts, right? The intercepts would be at 0, 2, and 3, 0. The bottom one is also in standard, so you find the intercepts. There's 0, negative 5. Looks like 10, 0. The solution, though, is where they intersect. Now, please, the solution to a system is an ordered pair. It's not a number, all right? I will get people to test, tell me the solution to that is 6. No, the solution is where they cross, 6, negative 2. Okay. All right, so as soon as you see standard form, all right, the go-to method is find the intercepts for graphing. So y-intercept, make x equal to 0. Divide by 3 here. Y equal 2, so the y-intercept is 0, 2. X-intercept, make y equal to 0. Divide both sides by 2. X equals 3, 3, 0. So that's our top one. So it says find the intercepts, plot the system, and find the solution. Okay. So there you go. I found the top one. Now we're going to find the intercepts for the bottom one. Y-intercept, x equal to 0. Divide both sides by negative 2. Y equals negative 5. Y-intercept 0, negative 5. X-intercept for the bottom one. Y equals 0. X equals 10. 10, 0 is the x-intercept right there. And again, I don't think I graphed the first one very well because I should have graphed it a little more accurately because it is that one right there. It is 6, negative 2. It said find the solution. So the solution is 6, negative 2. Now, again, if you're not sure, 6, negative 2 makes that math work out. 6 minus 2 times negative 2 is 6 minus negative 4. 6 plus 4, 10. 6, negative 2 makes the top one true. I'm saying this, all right, this is what I'm saying. 2 times 6 is 12. Plus 3 times negative 2 is negative 6. 12 plus negative 6 does equal 6. Remember, this is the only combination that will make both equations work out, right? Because it's the only point on both lines. This point is on the blue line and the red line. There's no other point that's on both. The point of intersection is the solution. Okay. Now, you should start thinking about what's your favorite way to graph. Right? When I was learning this, I did not like finding intercepts. So I would go 0. I was really good at finding the y-intercept 0, 8. Slope of 2 means over 1, up 2. And I could even go backwards if I need to. And I liked to graph that way. All right? And so that's the way I graphed. All right, but you don't have to do it that way, right? The y-intercept here is 0, 8. You could go and find the x-intercept. The x-intercept is where y equals 0. Subtract 8 from both sides. Negative 8 equals 2x. Divide by 2. X equals negative 4, so the x-intercept is negative 4, 0. Is that what I got? Yeah, it's right there. There's the x-intercept. So if you prefer to graph it that way, graph it that way. It's fine. Okay. So here, right, that's standard form. Let me use blue here so we show the different lines. So this is y-intercept, where x equals 0. And you get y equals negative 4, so the y-intercept is 0, negative 4. The x-intercept is where y equals 0. Divide both sides by 2. X equals negative 2. The x-intercept is negative 2, 0. And you graph it that way. But maybe I hate that method. Maybe I'd rather just change this into, right, slope-intercept. I could just subtract 2x from both sides, and I get y equals negative 2x minus 4, right? The y-intercept is 0, negative 4. The slope is negative 2, down 2 over 1, down 2 over 1, right? And I could plot it that way, or I could check my work that way, okay? So you have choices now. You can use the intercept method. A lot of students like that method, and you can use it on any form you want, all right? Or you can always use the slope and y-intercept the original way we learned by converting it. But once you're all done, you got to find the solution. What's the solution? Negative 3, positive 2, where the two lines intersect. All right, so this is what I was just saying, right? You can do this any way you want. All right, I'm going to, when it's in standard, I'm going to use find the intercepts. So y-intercept, make x equal to 0. Y equals 2. 0, 2 is the y-intercept. X-intercept, that's sort of sloppy. Make y equals 0. Divide by 2. X equals 3. 3, 0. All right. And so that's the top one. The bottom one, since it's already in slope-intercept, I'm going to start at 0, negative 5, and I'm going to go slope of 1/2, which means 2 over 2 up 1. Over 2 up 1, over 2 up 1. There's where they intersect right there, so I don't really need more than that. Whoops, my pen is not working. There you go. Remember, arrows on the end. Now, but say you hate that. You still can find the y-intercept is 0, negative 5, obviously, but then you can still find the x-intercept by making y equals 0. Okay, add 5 to both sides. 5 equals 1/2 x. Get rid of a fraction coefficient by multiplying both sides by the reciprocal. 2 over 1 times 5 is 10, so the x-intercept, ooh, I didn't graph that all that well. 10, 0. There you go. Okay, it's up to you. So what's the solution? The solution is 6, negative 2. Don't forget to find the solution where the two lines cross. It's the whole point. All right, again, we're practicing. So I'm going to do the top one using 0, 6 and a slope of negative 1/2. So 0, 6, slope of negative 1/2 means down 1 over 2. I like to draw that first, down 1 over 2. Might as well go until I hit the x-axis. Let's see. Ooh, I hit the x-axis way over here. But you can tell that's 12, 0, hopefully, right? Because there's 10. All right, and then this one. So I should draw the line before I go on to the next one. And then the next one, since it's in standard form, I'm going to make x equal to 0. And that's negative 1y equals 4, right? I have to divide both sides by negative 1 because there's a negative 1 there, right? And you get y equals negative 4. 0, negative 4 is the y-intercept. The x-intercept is making y equals 0. Divide by 2. X equals 2. 2, 0 is the x-intercept right there. Okay. Again, whoops, yeah, I was a little sloppy on my graph there. But it is, slope here is, right, if you convert this, you'll get, well, let's do it. So let's do a different color. So subtract 2x from both sides. You get negative 1y equals negative 2x plus 4. Divide both entire sides by negative 1. You get y equals 2x minus 4. Right, there it is. Slope was 2. I was a little sloppy with my graph, but there it is. And so the solution is 4, 4. Remember to find the solution where they intersect. Right, now you could graph this to check if this is a solution, but if you're unsure, like when you have a graph and like, you know, your graph ends up like between boxes because you're sloppy like Mr. Ben is, unfortunately, you can check. All right, so let's see if 8 works here. 2 plus 6. Yeah, that works there. So that's on this line. And let's see if it's on this line. 3 times x is 2 plus 8 equals negative 6. 6 plus 8. No. So what it is that point is on this line, but it's not on the other one, so it's not the solution, right? You're looking for the point that's on both. Okay. So here, y-intercept. X equal to 0. Divide both sides by 2. Y equals 3. So 0, 3. X-intercept. Make y equal to 0. X equals 6. So 6, 0. So we have 0, 3, and 6, 0 for the top one. Now these look suspiciously similar, don't they? What's going to happen here? Yeah, let's do the other one. Y-intercept, x equals 0. Divide by 2. Y equals negative 4. Y-intercept 0, negative 4. X-intercept, y equals 0. X equals negative 8. Negative 8, 0 is the x-intercept. So what's the solution here? These are parallel, so there are no solution. Now, how do could we be 100% certain? They certainly look parallel, right? This would be a good way to change them into slope-intercept, right? You subtract x from both sides. 2y equals negative x plus 6. Divide both entire sides by 2. Now, what's that? Right? That's negative 1 over 2. Y equals negative 1/2 x plus 3. That's this line right there. This one, subtract x from both sides, you get 2y equals negative x minus 8. Divide both entire sides by 2. That's y equals negative 1/2 x minus 4. That's this line in red. I did it in blue, unfortunately. All right. They have the same exact slope, negative 1/2. There is no solution when that happens. All right, so we're going to check to see if this is true. 5 equals negative 3 plus 8. Yeah, so this point is on that line. Now, 3 times negative 3 plus 5 equals negative 4. 3 times negative 3 is negative 9 plus 5 equals negative 4. Yeah, that's negative 4 equals negative 4. Yes, this is the intersection. This is the solution. It is the one combination that works in both. Good luck on the homework.